Hello, math application students, and welcome to your online lesson. Today we'll be talking about the Pythagorean Theorem, which is something that we should have learned previously in a geometry class, and probably even earlier than that, but a good review lesson for us nonetheless. Our learning intention is to learn to identify and use the Pythagorean Theorem, and we'll know we're successful when we can find missing sides of triangles and triangular figures using the Pythagorean Theorem. So the first question is, what is the Pythagorean theorem? And most of us are aware that the Pythagorean theorem is a squared plus b squared, which equals c squared. But just knowing that doesn't necessarily tell you exactly how to use it. So the thing we need to keep in mind is that a and b, which we're squaring and adding together, are legs of our triangle. Now, how do we know which sides of the three sides of a triangle are its legs? Well, the legs have to form the right angle. And again, you can see this little square here that indicates the right angle. So the two sides that are 90 degrees from each other, or form a 90-degree angle, those are your legs. And then your hypotenuse, your C, going in to its own side of the equation, is your hypotenuse, and that one is opposite of the right angle, or another way to say that is across from the right angle. If you think of the right angle box almost being like an arrowhead here that creates an arrow, well, it is literally pointing at our hypotenuse, and that's the one that goes all by itself. The other two sides, the legs, are being added up. And when can we use this? We can only use this if we have a right triangle. So if you have some other sort of triangle that does not have a right angle, then the Pythagorean theorem would not be appropriate for solving missing sides. So when can we use the Pythagorean theorem? We just mentioned that only for right triangles can we use the Pythagorean theorem. And what do we use the Pythagorean theorem for? Well, the Pythagorean theorem is used to find missing sides of right triangles. And since we have shapes that contain right triangles, like if I have a rectangle here, it also contains right triangles, because if I put a diagonal down it, again, I've got a right triangle. So we see right triangles anywhere. We see rectangles, squares, and then obviously any triangles as well. But again, it's used to find missing sides, and we can use it to find either the legs or the hypotenuse, but again, only for right triangles. So we're going to do some examples here. This first one is extremely basic, and it's basic because we barely have to do any algebra. We have two sides here, the 8 and the 6, and we know they are legs because, again, they are forming this right angle here. They join together. This side and this other side form the right angle. They join at the right angle, and so those would be our legs. As with any formula that we're using, let's start by writing the formula down. We've got a squared plus b squared equals c squared. A and b, once again, are our legs of the triangle, so we would have 6 squared plus 8 squared. And because they're being added, you could do those in either order. You could have 8 squared plus 6 squared as well. And then that's equaling our hypotenuse, which is x squared, our unknown. So as we put this together, we're going to have 36 plus 64, also known as 100, equaling x squared. Now, a common mistake of the Pythagorean theorem is that we forget to do the last step, which is we haven't found x yet. What we found is x squared. Well, we need to get rid of that squared. So we can either take it to the power of 1/2, which would cancel it out, or we can square root, which is probably what most people would do in this case. The square and the square root cancel out, so we're left with just x as our answer. Our variable's all alone now, and then the square root of 10 or 100 is 10. Now, technically, it's 10 or a negative 10, but since we're dealing with lengths here, there would be no negative answers, and so we just focus on the positive. Also, we'll usually have a label for these things because we're dealing with side lengths, but in this case, no units were given, so it's just 10 units long. Moving on to another example. Now, this one's a little bit different in the fact that, again, we have a right triangle, but our unknown is no longer the hypotenuse. It's no longer the one that's all by itself. So when we look at this, again, look for that right angle, which is right here. And what are the two sides that form that right angle? Well, we have this guy forming part of it, and then this other side here. So the x and the 24 are the two legs, and the one that the angle is pointing at would be the 26. So that's going to be our C, or our hypotenuse. So again, let's start by writing our formula down. We've got a squared plus b squared equals c squared. And we just said that x and 24 were our legs. So they're going to be replacing the a and the b. And then our hypotenuse, the one that is across from or opposite from the right angle, is the 26. So we're squaring that. All right. At this point, I might be tempted to reach for a calculator right away, and you certainly could do that. But I'm going to do a little bit of algebra first. So I'm just going to subtract the 24 with the exponent. So I have, x squared plus 24 squared. Well, let's get rid of the 24 squared. So those are gone. Whatever I do to one side, I'm going to do to the other. And so now I'm going to have x squared equals 26 squared minus 24 squared. And then for that last step, what I'm going to do is still square root. And so my answer is going to be the square root of 26 squared minus 24 squared. Now, if you wanted to get a number first from those, it'd still be a nice whole number. It's just one that I don't know off the top of my head. You can do it that way. But at this point, I can put this all in the calculator in one step. So let's pull up our calculator. And I'm going to do a square root, and I want to square root all of this stuff. So 26 squared, make sure I get out of my exponent, arrow over, minus 24 squared leaves us with a nice value of 10. Again, we could have done that other ways, right? If you wanted to just take the 26 squared earlier on in the problem, and then minus the 24 squared that we had, and then get the 100, and then square root that, we, of course, would have 10 still. So our final answer is 10. And again, it's good to check to make sure that it makes sense in the end. So our longest side will always be our hypotenuse, the one that was by itself. And the legs have to be shorter than that. Also, the legs have to add up to more than the hypotenuse. So if I did, this 10 that we got for x plus 24, it must be greater than our hypotenuse. Otherwise, if it wasn't, which it is here because we'd have 34, which is greater than 26, if you had two sides that were shorter than the hypotenuse, if this was the hypotenuse and this was one leg and this was another leg and they were shorter than their combined length was shorter than the hypotenuse, they wouldn't actually form a triangle. They'd have a gap right here. So everything makes sense as far as what we have. Again, the legs must be shorter than the hypotenuse, but if I add the legs together, they must be bigger. So that really can help you dial in as to whether your answer is reasonable or not. Okay, and that's all we're going to do for this one. Two examples, one where we found the hypotenuse and one where we did some algebra to find one of the missing legs. Until next time.